This video discusses how to access data objects that you're going to run across in R. So we want to know how to handle complex data sets, right? We're going to deal with pulling in data from different sources, and then we want to be able to manipulate, we want to be able to subset it. We need to know about these data objects. And so let's just start with one that we already have in our background. So there's this iris data set. So if you just go to your console, type in iris and hit return, you're going to see a data set. Okay? And so what kind of object is that iris? Well, we saw this str or structure function earlier that will help us identify the different attributes that that object has. So if we do str of iris, we're going to see that this thing is a data frame. There's 150 observations, which represents rows, and 5 variables, which represents columns. So remember, data frames are two-dimensional, so they have basically different vectors representing the columns that are all of the same length. So in this case, there are 5 variables, which are the vectors, each of length 150. So this gives us a pretty good idea what this object has associated with it. It's a data frame. These represent the column names, and then these are the values within the columns. So useful to know about there. What kind of characteristics does iris have? Well, we can actually look at the attributes of that thing to learn a little bit about that. So this attributes function will give us information about our data set. So in this case, attributes of iris is going to return the named list that you see here. So we got to dig back here for just a second. A list, remember, is a one-dimensional vector, but each element of that list can be of different types, can be completely separate. So when I say that this thing returns a named list, this is the first list element up here, this names, and this is a vector of 5 things. Here's the second list element, class, and it is a data frame. And here's the third list element, row names, which just happens to be 1 to 150, so sort of the default row names. So those two functions, structure and attributes, are going to tell us a lot about whatever kind of R object we're dealing with, and it will help us to sort of get at the different pieces that we want. So what things do we have to deal with? How do we get at them? So let's talk about that. Well, for a given data set, for instance, we may want to just grab a single value from there. We may want to just get one column. We might want to return just the numeric columns, just a row, maybe just rows corresponding to one particular setting of a variable. So for instance, I might want to just grab the rows corresponding to species Setosa, for instance. How do I do that? And then lastly, we might want to access these attributes to change them, modify them, or use that information somewhere. So that's what we're going to talk about in this video. So let's start with the basic building block one, right? The atomic vector, and then we'll work our way up. So with atomic vectors, remember that when R returned them, it used a square bracket and said, well, this is the first element, and started listing them. And then when it ran out of room to print, it gave us a square bracket and said, well, this is the 18th element, and continued showing them. So this is actually giving a little bit of a hint as to how to access a vector. So you can access a vector using these square brackets. So for instance, if I do letters and then give square bracket 10, I'm going to get the 10th element of that vector. And so if you extend that logic, right, if I just give it a number, remember, well, we haven't really talked too much about this, but R doesn't really have a scalar. So if you give it just a single number, it converts that to a vector of length 1. So this is really feeding the letters, the square bracket function, a vector with one element in it. That element is 10. So now if you extend that logic, we can feed it this sequence 1 to 4. Remember, 1 colon 4 is going to return a vector 1, 2, 3, and 4. So now if I use square brackets with letters there, it's going to return the first, second, third, and fourth elements. Likewise, I could just give it whatever sequence of elements that I want, so 5, 10, 15, 20, 25, for instance, or return those in this case. Not only that, but you can actually just feed the square bracket function a vector that you've saved somewhere else. So for instance, here I'm saving x. This is a vector with 1, 2, and 5 in it, and now I'm saying letters and then square brackets to say I want to index this using that x object, so it's going to return the first, second, and fifth elements of letters. So that's generically how you would get at different values within a vector. So now let's extend that to our next type of object that we often deal with, the matrix. And so if you print out a matrix, so let's say we created one. We saw how to do that with this matrix function. It's got 2 columns, and based on the number of values we gave it here, it ends up having 4 rows. If we look at that, notice how it prints out by default. So you see that it's still using square brackets, but now there's this comma that's associated. And so that gives us a hint as to how to access these different pieces. So if I did 1 comma and left it blank, I should get this entire first row. If I do blank comma 1, I will get this entire column. And if I want, say, the 1, 1 element, I could do 1 comma 1 to get at that. So here's some examples of that. So we access our matrix elements with these square brackets and a comma, the first element representing the row, second one representing the column. If you leave one of those blank, so here I've left the first row blank, the first index blank, which represents rows, you get that entire row back. So I'm saying all of the rows where we're at the first column. And you can do all the same kind of things that we did with vectors. So here I'm saying 2, 3, and 4, so the second, third, and fourth rows, and the first column only. So that returns there. One thing to note here is that this is, the thing that's being returned is actually being simplified as much as it can in this case. So for instance, what's being returned here is a vector, vector. But then down here, there's no way to return, well, there is a way if you stack it, but there's no reason to return what we want to grab here as a vector. It would make more sense to return as a matrix, and so it does that. So this is saying the second and fourth rows, all of the columns. So here's the second and fourth rows, both columns that we had. So we'll return that as a matrix. Now, you can use column names on a matrix and then use those to grab the columns rather than this sort of using the numbers to index it. So let's just see how to do that. If you went into help for the matrix function, you would say that there is this. You would see that there is this dim names argument that you can pass, and so dim names is going to specify the dimension names. And so the first dimension represents the row names, the second dimension represents the column names. And if you dig into the actual documentation of what you need to do for dim names, you need to give it a list with the first element of that list corresponding to the row names and the second element of that list corresponding to the column names. Okay. And so I don't want to specify any row names, so I'm going to use this special object called null in R. So this is basically saying I'm not telling you anything for this. This is nothing. And then I'm giving it a vector of like 2, since I have 2 columns, to represent my column names. Okay. And so it keeps the default row names because we gave it that null. And then now the first row or first column is called first, second called second. Okay. But again, in order to figure out how to do this, you would need to go into the help for the matrix, look at this dim names argument, and figure out exactly what you need to feed this thing. But now that we have column names here associated, we can actually access a column using the corresponding name. So I can do mat square brackets, and then I want all the rows. I want the column that is called first. So it's going to return what you see there. All right, so what about structure and attributes of a matrix? We saw it for a data frame already. What's associated with the matrix? Well, remember, for a matrix, all the elements need to be the same kind. And so you'll see here that what gets returned is, this is an integer, essentially an integer array. So we don't have any decimals or anything floating around. So an integer array, it has 2 dimensions. We're using square brackets. There's a comma, so there's 1 dimension, 2 dimensions. And then these are the values. Here are the dim names, so the row names and the column names. You can then look at the attributes as well, which gives a little bit of the same information. So this tells us the dimensions. This is something that's associated with a matrix. 4 rows, 2 columns. Dim names. So to remind you, remember attributes is going to return a named list. So this is the first list element. It's a dim is the name of it. The second list element on attributes is dim names. And we actually, remember, specified dim names as a list itself. So within there, now there is a named, there is now a list, first list element and a second list element. Okay. And this is actually telling you how to access that, which we'll see in a little bit as well. So you can use a $sign to access a named list, and then square brackets, double square brackets to access, say, the first list element. So I know it might seem a little bit confusing, but we're going to keep piecing through this as we go. Okay, so we know how to access vectors. We use square brackets. We know how to access matrices, square brackets, but we need a comma to represent rows and columns. Data frames are, again, two-dimensional, so hopefully we're going to be able to utilize some of that same square bracket kind of notation, which we will. But we're also going to be able to do some other fun things as well that makes our lives a little bit easier. So remember, looking at the structure of Iris, this data frame, there are these $ and then names for each one of the columns. So this is actually telling us that this is one way that we can get at a particular column. We can utilize this $ operator from our data set. But the basic way you could do it is that square bracket. So we're still in 2 dimensions, so square bracket, first dimension, comma, second. You can do that. But what's really nice, so we're still in the square bracket notation here. So here we're giving it a character vector of 2 things, so it's going to return those 2 columns. But what's really nice about data frames is we can utilize this $. So we saw that we had sepal.length was one of our variable names. So if we do iris $sepal.length, it will just return that column. And notice that this returns a vector as well. And so this is really convenient because our studio will actually do completion for you on this. So if you go into your console, you type iris $, and then hit tab, it will give you all of the choices for the different column names. So you don't necessarily need to remember what each one of your columns is called. You can just hit tab and then scroll through it. When you find the column that you want, you hit tab again, and it will complete that so that it's really easy to type out. You don't have to type out that whole thing. It just returns it for you. So here we are in our studio. And so again, if I type in iris, R is actually going to tell me all of the different types of things that are in my background or in my global environment that exist for that name. So there's an iris3 as well. I'm not exactly sure what that is, but we want iris, so we're just going to go ahead and put $. And this is now going to give me access to whatever columns I have for that thing. So I can scroll down to petal width and hit tab, and now if I hit enter, I grab that column. And again, this saves you from having to remember what the columns are called. You can just use that auto completion to do it for you, which is very nice. Okay, so now we've seen vectors, we've seen matrices, we've seen data frames. How do we deal with lists, our other common data object that we talked about? Well, again, we've seen in a couple things that have been printed out this sort of double bracket notation. And so that double bracket notation is R's way of saying that this is the first list element. So that's one way that you can actually get that thing returned, is by indexing it with that. And so I've just created a basic list with 3 things in it: a character vector of length 1, numeric vector of length 11, and then a numeric vector of length 1. So you can see that I have these double square brackets representing each one of those elements, and then within there I would have vectors. So if I wanted to get at just the first list element, I could do x bracket bracket 1, and that would return that first element. X bracket bracket 2 returns the second one, bracket bracket 3 the third. And you can actually see that since I'm returning a vector here, I can actually index that vector at the same time. So if I put square brackets after what you see there, I'm now saying I just want the 4th and 5th elements of what gets returned from x bracket bracket 2. So you can do your sort of indexing down levels with one step of code, which is kind of nice. What's really nice is very similar to data frames. If your list values, if your list elements have names to them, so if you have a named list, you can access them with a $ as well. So if we look at this thing here, this X list that we created, look at the structure of it, notice that it gives the $ like it did for the data frame, but then there's nothing after it. So these are unnamed list elements. And so we're not going to be able to call them by their names because they don't exist. But we can give them names. So say when we create our list, we could say, I want to name my first list element first, second one second, and third third. Now, if you ran this same structure, you would see first, second, and third show up. And so just like we did with a data frame, I could then do the $ operator. X $second would give me my second column. And so here's a connection to make. Data frames are actually just lists where each list element is an equal length vector. Okay. So if I look at this data frame, this structure of it looks exactly like what it looks like for a list, right? We have dollar signs and then what each one of those things represents, what each one of those elements represents. So with a data frame, which is a special type of list, we now are saying that, hey, I have these names for them, and since they are all of the same length, it's okay to put them in a data frame. So if you have a list with, say, 3 elements, each of length 50, it's not going to be a data frame unless you cause it to be a data frame. So you can coerce it to be a data frame or just create it. But basically, that's the connection that you would see there. Lists have the dollar sign. Data frames do as well. Data frames are actually just lists of equal length vectors. Since these are lists, you can actually access, say, the second column, so the second list element with double square brackets if you wanted to. There's no real need to because it's easier to use the sepal.width name that's given there, but you can absolutely use double square brackets here as well. Okay, so lastly, we've looked at these attributes a bit. We might want to change them, right? We might want to change the names of our columns or something like that. So how do we deal with that? Well, we saw that attributes of, say, Iris would return a named list. And so we can actually see exactly what that named list is by running structure on that. So the structure of the attributes of Iris is a list of length 3. It's a named list with these 3 named objects represented by what you see there. So now if I wanted to go in and change, say, my column names, I can do it by changing this attributes list element. So if I type attributes of Iris and then $names, that's going to return the names of the columns from Iris. And so you can see that that's that vector of length 5. So we can actually overwrite the given elements as well. So I can say grab the first element of that, sepal.length, and let's store in that sepal_length. So I'm overwriting that name. And you can see now when I run that, it's changed that first list element, that first character vector element. So you can go and change your column names. You can go and change individual values with this same kind of thing as well. Now, changing column names is something that you want to do quite a bit. It comes up a lot. So there are what are called helper functions, so that you don't have to go into this kind of sort of nasty looking notation. So there's a helper function called names, which will basically return exactly the thing that you return by doing attributes Iris $names. And so with this helper function, you can more easily say replace an element. It's a little bit less cumbersome looking. So here what I'm doing, grabbing the names of Iris, and with the second element, I'm going to replace that. I'm going to store in that sepal_width. One other thing that's really nice about using lists and data frames is that you can use partial matching. So partial matching means that you don't need to type in the entire thing. This was a bigger deal before RStudio was big, where it does the auto completion for you. But if you used to, just use text editors to do this kind of thing, you wouldn't necessarily know the whole name, but you know what it starts with. So you could do something like Iris $SP, and the only column that starts with SP is the species column. So it does partial matching and realizes that must be what you're looking for. And you can do the same thing using the double square bracket notation, but you have to add this argument exact equals false to do that. So here I'm doing petal.length, but I didn't complete length, but I'm saying it doesn't have to match the name exactly, just use partial matching instead, and it returns the appropriate column. Okay, so we're now we understand hopefully a good bit about how we're dealing with these R objects, right? We can understand their attributes and structure with these 2 functions that you see here. And once we know what kind of object we're dealing with, we can then access and subset using the different things that we talked about here. So square brackets for vectors and matrices, double square brackets for lists, or if we have named list or data frames, we oftentimes use this $ instead.